Hello dear students, hope your preparations are going quite well. Now in today's video I am going to discuss the topic of waves, and this video will be useful if you are going to appear for your NEET and JEE in 2020. Okay. Now the fundamental of waves is like, first is classification. Okay. So this classification means types of waves. Okay. So you have longitudinal waves where the particles of the medium, they vibrate parallel to direction of propagation. Example is sound wave. Then you have transverse wave where the particles vibrate perpendicular to direction of wave motion. Example is vibration in strings. Okay. Light wave is also a transverse wave. Now there is another classification based on necessity of medium, that is whether a wave requires medium for its propagation or not. Now that is called mechanical wave and non-mechanical wave. Mechanical waves are those waves which requires medium for their propagation. So sound wave is a mechanical wave, and non-mechanical wave are waves which do not require medium for their propagation. Okay. An example is light wave, electromagnetic wave. They don't require medium for propagation. Okay. Now this is all about classification. So next topic is the wave equation. Wave equation. See, suppose this is a wave, simple transverse wave, okay, and it is propagating in this direction, okay, and particles, they are vibrating like this, okay. So the equation of the wave, it is written in the form y is equal to a sine kx plus minus omega t plus minus phi. Okay, this is the general equation of the wave. Okay, now we will see what is the meaning of each term involved in this equation. Okay, now this y, this represents the displacement of the particle of the wave. Okay, now wave is propagating in this direction, particles are vibrating like this. Suppose this is your x-axis and this is your y-axis. So particles are vibrating along y-axis and wave is propagating along x-axis. So this y represents the displacement of the particle. Okay, this a, this is the maximum displacement of the particle and it is called amplitude. Okay, now here this terms sine kx minus omega t plus minus phi, here you can have plus minus, here you can have plus minus, but this entire term, this is called the phase. This is called the phase. Okay, and this kx minus omega t. Okay, now this term I can write it as, suppose, kx minus omega t, or I can have kx plus omega t. Okay, now for a given wave, this entire phase is a constant. Okay, now if this entire term is a constant, that means this term, it has to be a constant, and this term, it has to be a constant. Okay, now if this is constant, suppose this is constant. Okay, now if I differentiate this, I have k dx minus omega dt is equal to 0, or dx by dt is equal to omega by k. Okay, now this dx by dt represents the displacement of wave per unit time. So what is it? It is the wave velocity v. Okay, so this is wave velocity. Okay, so this ratio omega by k represents wave velocity, and see here, this v is equal to omega by k, and this omega by k is a positive quantity. Okay, now what is the significance of this positive quantity? To see the beauty of that, let us differentiate this also, because if kx minus omega t is constant, then kx plus omega t, this also has to be a constant. So this is k dx plus omega dt is equal to 0, or dx by dt is equal to minus omega by k. Again, this is the wave velocity. Okay, so here we are getting wave velocity as minus omega by k, here we are getting wave velocity as plus omega by k. So in one case wave velocity is positive, in another case wave velocity is negative. So what does it mean? It means If wave velocity is positive, that means the wave is propagating along positive x-axis, and if wave velocity is negative, wave is propagating along negative x-axis. Okay, so that means if we have equation like this, y is equal to a sine kx minus omega t and y equal to a sine kx plus omega t. So if we have kx plus omega t, as in this case, this is a wave propagating along negative x-axis, and if it is kx minus omega t, it is a wave propagating along positive x-axis. Okay, wave velocity will be positive in this case. Okay, so now we have understood what is the significance of this sign. Okay, it will be either plus or minus depending upon the wave, whether it is propagating along positive x-axis or negative x-axis. Okay, now this phi, this is called the initial phase. Okay, this is the initial phase. Now how to find the initial phase? In this wave equation, you substitute x equal to 0 and t equal to 0. Okay, now if you substitute x equal to 0, t equal to 0, what remains is called the initial phase. Okay, so this is initial phase, and this entire thing is called phase. Okay, now what about this k and what about this omega? Now this k is called angular wave number or wave vector. Now k is equal to twice pi by lambda, and this omega is called angular frequency. Okay, so omega is equal to twice pi by t. Okay, now if I divide these two quantities, omega by k, what do I get? I get lambda by t. And what is lambda by t? This is wave velocity. Okay, so this is omega by k is wave velocity. Wavelength, ratio of wavelength to time period, that ratio is called wave velocity. So omega by k is also wave velocity. Okay, so I hope these things are clear to you. Okay, now let us write this equation again. Y is equal to a sine kx minus omega t. Okay, let initial phase to be 0, so we have taken phi to be 0, and this is kx minus omega t, so this is a wave propagating along positive x-axis. Okay, so see this equation represents this wave, so this is y-axis and this is x-axis. Okay, so now if I find dy by dx, so that means this equation represents this wave, and what is this wave? This is in the form of a curve, sine curve. So if I am finding dy by dx, that means I am finding the slope of the wave. Okay, so what will be the value of dy by dx from this? It will be a, this sine differentiation is cos kx minus omega t into k. Okay, so this dy by dx, it is equal to ak cos kx minus omega t. Okay, next let us find dy by dt. dy by dt is the particle velocity. Okay, so dy by dt will be, if I differentiate this with respect to time, so a, this becomes cos, sine becomes cos kx minus omega t, then here I have to differentiate with respect to time, so this is independent of time, here we have time, so this is minus omega, so dy by dt is equal to minus a omega cos kx minus omega t. Okay, so if I substitute this, see here also I have got this cos kx minus omega t, so I substitute the value of this cos kx omega t from this equation, so it becomes dy by dt is equal to minus a omega, this becomes 1 by ak dy by dx, correct? So this a terms cancels out, omega by k is the wave velocity, so dy by dt is equal to minus v dy by dx. Okay, so this is the relation between particle velocity and wave velocity. This is particle velocity is equal to minus wave velocity multiplied by slope of the wave. Okay, so this is the relation between particle velocity and wave velocity. Followed? Next topic is speed of wave. Okay, now for transverse wave, Transverse wave, in class 11, the transverse wave, when we are dealing with transverse wave, we are studying the transverse wave in strings. Okay, transverse wave in case of light, that we will be studying in class 12, that is a part of class 12 syllabus. Okay, so this transverse wave in string, the formula is V is equal to square root of T by mu. Okay, V is the speed, T is the tension in the string. Okay, this T is the tension, and this mu is mass per unit length, mass per unit length of string. Okay, mu is mass per unit length of string. Okay, now this mu can be written as m by L. Okay, this is mass of the string, L is the total length of the string. Okay. If I multiply this numerator and denominator by A, where A is the cross-sectional area, then this length into area, this is volume, correct? This is volume, and mass by volume is density. So this mu can be written as rho into A. Okay, where this rho is the density, and A is the area. So if I use this over here, this velocity of transverse wave or speed of transverse wave in a string, that can be written as square root of T by rho into A. So these are the two formulae to calculate the speed of transverse wave in a string. Okay. Now for longitudinal wave, okay, the general formula is V equal to square root of elasticity factor divided by inertia factor. This is the general formula. Okay, so if a longitudinal wave is propagating through a fluid, okay, or a solid, so in that case we have V is equal to square root of B by rho. B is the bulk modulus, this is bulk modulus, and rho is the density. Okay, now if the longitudinal wave is propagating in a rod, in that case the speed V is equal to square root of Young's modulus by rho. This Y is the Young's modulus. Okay, now based on this we have this speed of sound wave propagating in air. The Newton formula is V is equal to square root of P by rho. This is Newton formula. Okay, and Laplace formula, this is Newton formula. Laplace formula is V is equal to square root of gamma P by rho. So the Newton formula was wrong because Newton assumed that sound wave propagation is a isothermal process, and using this formula the velocity of sound or speed of sound in air was found to be 280 meter per second, but actually it is around 330 meter per second. So this there was a mistake in this formula. The correction was done by Laplace, and that is called Laplace correction, and Laplace proposed that sound wave propagation is not a isothermal process but it is an adiabatic process, and he obtained the formula as V equal to gamma P by rho, where gamma is the adiabatic gas constant. Okay, now it is related to degrees of freedom by the relation gamma is equal to 1 plus 2 by F. Okay, where F is the degree of freedom that you have studied in KTG. So using this expression the velocity of sound wave was found to be 330 meter per second in air. Okay, so these are the two formula. This is Laplace formula, this is Newton formula. Newton formula based on isothermal process, and this is based on adiabatic process. Okay, now from this, okay, we can analyze like on what factors the velocity of sound depends. Okay, now velocity of sound is independent of pressure, because this term P by rho, this can be written as RT by M. Okay, this is again you have studied in thermodynamics. So if the temperature, see, if pressure changes, then density also changes such that the ratio remains a constant. Okay, if pressure is increasing, density also increases. If pressure decreases, density also decreases. Okay, so because of that this ratio is a constant, and we say that pressure has no influence on speed of sound. Okay, and this this expression, so I can write this expression as V is equal to square root of gamma RT by M. So speed of sound is directly proportional to square root of temperature of the medium. Okay, if temperature increases, speed of sound also increases. Okay, the other thing is speed of sound is inversely proportional to square root of density of the medium. If density increases, speed of sound decreases. Okay, so these are the factors affecting speed of sound in air, or that matter in any other medium. Okay. Now superposition of waves, this leads to few phenomena. Like if you have identical waves, okay, identical waves traveling in same direction but having a constant phase difference, and they undergo superposition, then we have the phenomena called interference. Okay, so for interference we will have two identical waves. Okay, they will have a constant phase difference traveling in same direction undergoing superposition. Then we have stationary waves. Now stationary waves are formed due to superposition of two identical waves traveling in opposite direction. Okay, so that results in the formation of stationary waves. So another phenomena that arises due to superposition of waves is the beats. Okay, now these beats arises due to superposition of identical waves having slightly different frequencies traveling in the same direction and undergoing superposition. Okay, now in interference, as I told you, now in interference we have two identical waves traveling in the same direction undergoing superposition, and they have a constant phase difference. Okay, so we have two waves, y1 is equal to a sine kx minus omega t, and y2 is equal to a sine kx minus omega t plus phi. Okay, so this phi is the phase difference between the two waves. Okay, so the resultant wave formed due to superposition of these two waves will have equation y is equal to y1 plus y2. This is called principle of superposition. Okay, so if you simplify this, you will have y is equal to twice a cos phi by 2 sine kx minus omega t plus phi by 2. Okay, so this is the equation obtained by adding these two. Okay, so this term represents the amplitude of the resultant wave. Okay, now that means amplitude will be maximum and it will be equal to twice a when this term is equal to plus minus 1. Okay, so this can have a maximum value of plus minus 1 and minimum value of 0. So when this is 0, this amplitude term 0 and then displacement is 0, isn't it? And when this term is plus minus 1, then the amplitude is maximum. Okay, so for phi is equal to twice n pi, we have this amplitude as a maximum value, and for phi is equal to twice n plus 1 times pi, we have the minimum amplitude. Okay, so what is this phi? Phi is the phase difference. So when phase difference is an odd multiple of pi, amplitude is 0, and phi is even multiple of pi, we have maximum amplitude. Okay, so this is when amplitude is maximum, we have called constructive interference. Okay, so this is the condition for constructive interference. Constructive interference, and this is the condition for, here we will have a 0 amplitude, 0 displacement. So this is destructive interference. Destructive interference. Okay, now this is all about interference, and next is we have stationary waves. Now stationary waves, see, these are formed due to superposition of two identical waves traveling in opposite direction. So we have one wave y is equal to a sine kx minus omega t, another one y2 is equal to a sine kx plus omega t. Okay, so this kx minus omega t is a wave propagating along positive x-axis, kx plus omega t is a wave propagating along negative x-axis. So these two waves are undergoing superposition. On superposition we have the formation of a stationary wave. So this is how a stationary wave looks. So these positions are called nodes. Okay, nodes. And for node, okay, so these are nodes, and the position at which we have maximum displacement, this position are called antinodes. Okay, nodes are positions of zero displacement and antinodes are positions of maximum displacement. So as you can see, this looks like one wave from this position to this position, isn't it? This is one wave. So what will be the distance between these 2 points? It will be lambda. So if this is lambda, that means this will be how much? This will be lambda by 2. So what is this? This is a node, this is another node. So successive nodes are separated by distance of lambda by 2. Similarly, two antinodes, they are also separated by distance of lambda by 2. So whether it is antinode or node, successive antinodes and successive nodes, they are separated by distance of lambda by 2. And what will be the distance between one node and one antinode? If this is lambda by 2, this will be how much? This will be lambda by 4, isn't it? Okay, so these are some of the fundamental concepts of stationary wave and interference. Okay, one more thing you need to know, like see, if I am writing y is equal to a sine kx minus omega t. Okay, so this is a equation of progressive wave. Okay, so this wave is propagating along positive x-axis, so we say that it is a progressive wave. Okay, but for stationary wave, okay, so this is a stationary wave. So this stationary wave is formed due to superposition of two identical waves traveling in opposite direction. So we have y is equal to a sine kx minus omega t and y2 is equal to a sine kx plus omega t. Okay, now on superposition we have the resultant wave as y equal to y1 plus y2. This is principle of superposition, isn't it? So what if you add these two equations, what do you get? So if you add these two equations, we get y is equal to twice a sine kx cos omega t. Okay, so this equation represents a stationary wave. Okay, so what is the difference between this equation and this equation? See, here kx and omega t, they occurs together with this sine function. So instead of sine you can have cosine also, but they occur together. Okay, but here kx and omega t, kx is with sine, omega t with cos, two different trigonometric functions. Okay, so that is the identifying mark for a stationary wave. Okay, for stationary means if you are asked to identify whether this equation is a progressive wave equation or a stationary wave equation, so just by looking at the equation you can say that this represents a stationary wave, because kx and omega t, they occur separately. Here they are together. Okay, so for in progressive wave they will be together, in stationary wave they will be separate. Okay, so this is the first part of the video, and I will be uploading the other parts also, but before that I want a feedback from you whether this kind of discussion is beneficial for you for your forthcoming NEET and JEE examination. Please do give a feedback whether this is good or not, because if you want to have a detailed discussion, then also I will try, but there is a shortage of time, so I want a feedback from you. Okay.